So now that you know an ionic compound is composed of ions, which are going to be a cation, that's a positive charge, and an anion, that's a negative charge, let's put them together and we're going to write names of ionic compounds, but we're going to be writing with, we're going to start by writing chemical formulas of ionic compounds. So the couple rules, the cation, the positive charge, is always on the left. It always leads in the chemical formula. The cation, the positive charge, is always leading, and the negative charge, the anion, is always following. So cation on the left, anion on the right. The name, therefore, is also always going to reflect the cation on the left and the nonmetal or the anion on the right. So metal cation, nonmetal anion. And that nonmetal anion has that IDE. Okay, so we're going to see that in the naming of the full compound, and we just saw it in the naming of just the anion, where you add the IDE. Those are the negative charges, those are the nonmetals that you take out the last few letters and you add the IDE ending. So this is, for example, the ionic compound that's formed from a sodium ion. So sodium, remember, is a metal, and metal, you just keep the element name. And then fluorine, this is a nonmetal, and this is where the fluorine ion that forms an anion, you take off the last few letters and add IDE, so it's sodium fluoride, and that's the compound in toothpaste. So NaF is the ionic compound chemical formula, and we're going to see how we write these chemical formulas by taking the charge values and crossing them over and down, so that the charges of each of these ions will balance out. So for sodium fluoride, this is the chemical formula. This is the symbolic view. And this chemical formula does not have any plus or minus signs, even though the ion, sodium, was a positive and the ion, fluoride, was a negative. But when you put them together in the ionic compound, those positive and negative charges cancel out so that this whole compound has no charge overall. So it's called a neutral compound when you have the ions coming together to form a compound with no overall charge because the charges balance out, okay? So, and for ionic compounds, you will never, ever see, or you shouldn't, at least in the work we're doing, these prefixes that are used for covalent compounds. These are prefixes mono, di, tri, tetra, penta, hexa, hepta, and so on. These are used for covalent compounds. But what you will see for ionic compounds in names are those Roman numbers. That's called the stock system naming. That's when you have a metal ion that can form more than one charge, like iron +2 ion is called iron Roman number 2. Or the common name, you have the OUS and IC endings, ferrous for iron +2 or ferric for iron +3. Okay, so we'll get into the naming, but I want to show you some more examples for writing the chemical formulas. These would be the two ions coming together for calcium. So calcium is a +2 ion because it's in family 2, and oxygen is a 2- ion because it's in family 6. When these two ions come together, the ionic compound chemical formula is written CaO, and that's because it takes one of each of these, a 2+ and a 2- ion, to balance the charges, and one of each of these will result in an overall zero charge or neutral ionic compound. This is another example where you have a sodium ion, which has a +1 or a 1+ or just a plus, okay? And sodium with sulfur, so the sulfur ion, the anion that forms is 2-. That's because sulfur is in family 6A, okay? So those all form 2-, and oxygen was an example of 6A as well. So when these two ions come together, it's not one of these and one of these. It's in fact what's going to require canceling out the 2- charge is going to require 2 of these positive ions for these two 2- charges coming from the sulfide ion. So you need to balance out the charges in order to form a neutral compound. So just a tiny bit more before we go into the chemical formulas and crossover rule. The transition metals that I mentioned for iron or tin or lead or copper, zinc and silver and chromium, those are on that cheat sheet that I showed you last time. Those are metals that have more than one charge for 5 of them, and you need to add that Roman number or use the common name ending OUS or IC in order to indicate the ion that it is, because the cation can be more than one possible. You can't just call it iron. You have to indicate if it's iron 2 or iron 3. So we'll see that in writing names. And you also have that zinc and silver, although they are in the B series, they're transition metals, they only form one possible ion. So it's not called zinc Roman number 2. It's not called silver Roman number 1 because there's only one possible ion. Those are just called the zinc ion and the silver ion, just as you would name sodium the one ion that it forms. So when writing chemical formulas for ionic compounds, start with the metal. That's the metal cation, and that's going to be written on the left. And you want to write the element symbol with the charge value as a superscript. So that's a small raised number. And then to the right of it, you're going to write the non-metal anion, also with the element symbol and the charge value as a superscript, a small raised number. So this will look like this for lithium. That's in family 1A, it's a 1+ ion, and oxygen's in family 6A, it's a 2- ion. Then what you have is what's called the crossover rule, where you cross the number values over and down, number value over and down, so that the number values no longer are superscripts, now they're subscripts, and they also no longer belong to the original atom or the original ion. This lithium, this 1 now belongs to the oxygen as a subscript, and it's not written as a 1 because just having the element symbol means there's 1 of these oxygens. The 2, which was the superscript of oxygen, now becomes a subscript of lithium, and means that there are 2 of these lithium ions. So that adds up to create a neutral compound when you have 2 of the positive charge lithium and 1 of the -2 or 2- charge oxygen. So that's called the crossover rule, and it is writing the chemical formula to create a neutral compound. It should have no superscripts, no plus or minus signs, and no charge values. It should only have subscripts in the chemical formula. All right, let's put this knowledge to work on this lecture worksheet.